So happy to come and talk in front of you. And in 1974 to 79, I did my 5-year course in chemical engineering, and the first 3 years doing all the mechanical, civil, electrical, geology, everything. And talk to you guys. And I want to keep this course very meeting more interactive. So I just wanted to know how many of you are in the final year and third year? Raise your hands. How many of you are from chemical engineering? All right, so just want to make sure. Okay? All good? So this is about me. I graduated here and then worked in Delhi. Then I went all the way to the cities and spent many years there. Ranganathan, one of our professors, he got me interested in instrumentation control. So I specialized in process control. And then I've been using computers since 1979. So I started programming in computers 2004 in 1979 from first job, and still I enjoy programming in Python languages. So some of you guys need any help in future, feel free to contact me. This is my Gmail and this is my LinkedIn profile. So the agenda today is we're going to talk about industrial revolution, because most of you guys are going to work for the industry, either as a consultant or as a designer or a supplier of equipment, or you're going to just run the factories operating, right? So industry is very important for chemical engineers, and I'm going to go through the stages of industry and why the data engineering is important. And we're going to talk about first principles in science and engineering. So how important it is, whatever you're learning this 4 years, and even before you are in high school, is going to help you. Because more and more automation comes, more and more artificial intelligence comes, more and more important the fundamentals becomes, right? So that is why the catch-up on fundamentals, mathematics, those things are very important, because I know I have rushed through some of those courses, but when I went and started working on more automation, I realized and then refreshed my fundamentals. So I'm going to go through some of these examples we have time, how you can use this kind of AI to refresh our knowledge. Okay? Then we're going to talk about what is data science, AI, large language model, and then we'll conclude and open for Q&A. Feel free to stop me, raise your hand, and I'm happy to answer your questions. And I have a question and answer in the end. But feel free to ask, because there is no question that is too hard. Because every time people ask questions, we learn. You learn. All of us learn. So feel free to talk. There's no inhibition, right? That's the most important these days. Okay. So, first revolution, industrial revolution, happened in 1940, when they started having printing presses. Because that is where people are able to communicate. Because everything was with some people, and somebody tells, and more people tell, then carry on over generations. It gets muted, they put their own theories and things like that. So only when 1440, when they started printing press, that's where the communication happened. We had a lot of things going around. Earlier, it's only one king will write something, you go to the other king, and you will agree, and then it's an exchange. But now, these is the first stage. Second one is mechanization. That's what happened in the 18th century. So they were throwing coal and then start creating steam, and the steam was able to run the looms, and then the steam engine was able to move. So we were able to move goods from there. Or else, what we were doing, we were all sitting in one village, and then with 30 kilometers round or even 15 kilometers where the bullock cart can go overnight. That is what is the maximum material that we are exchanging. But once the mechanization happened, steel engineering started having transportation, textiles. Then stage 2 is they said, there's a lot of demand and we have to make more for more people. And that is where the second industrial revolution happened. We had electricity, we had factories, and then we were making more of same thing, more and more, 100,000. And what happens is, most of us, the way that our education system, where we compartmentalize, hey, you're going to be a chemical engineer, you're going to be a mechanical engineer, you're going to do this. Many of these things, even our education systems, were all siloed in such a way that we were able to make mass production. It's called cookie cutting. So this is what is a cookie cutter technology came in. Because you have to move, you have to make money. So even our education systems and everything was there. And then slowly education systems are changing, and if you see the technology, then the third technology is where the communication happened. Because what happened is the computers came in, and we started having computers central. And initially computers came because they had to run our payroll and other things. But later on, we started using computers to move the valves and move motors, run the motors. So we control the whole thing from one place. That's where this third industrial revolution came, where electronics, information, technology, and industrial automation. So you can see here, that's why you have programmable logic controllers, distributed control systems, and those things came in. So this is in mid-20th century. Then what happens is, even though we had all this, but they were still operating in silos. So what happens, there'll be a maintenance department, there'll be an electrical department, there'll be a civil department, and everybody will be using computers, but they'll be transferring data through papers or through emails. Or they just take a phone and talk. So what was happening is, we were still living in silos. Only thing we were automating, whatever was the process that was already needs change, but we were just automating. Then they realized, when we have to go to fourth revolution, in the fourth revolution, what happens is, we have to go and start communicating. So the digital communication came in. So we are now in, most of the guys who are successful, they are in the fourth revolution. When you come to fourth revolution, you will have a big question. Hey, is it an IT company? That's why people ask, I want to go to IT. No, what happens is, as a chemical engineer, if you're making, let's say, if you're a mechanical engineer, if you're making Tesla, what do you say? Is Tesla industry, or is IT, or it is a workshop? You don't know. They are very, very, very fuzzy. Same thing, you take Amazon. What makes Amazon successful? Is that because they are moving the packages, or it is the system they have? So it's all combination of two. That's where the companies, most successful companies today, where the stocks are going up, where the values are high, and the richest factories, they are all the one. You don't know the difference, whether it's an IT company or it's a manufacturing company. So that is the very important part, because that's why we have to start thinking that IT, information technology, and OT, the operations technology, they are all integrated. So if we start thinking that IT is different than operations technology, that means we are still living in the age of mass customization. That's the main thing I wanted to say. At some point of time, engineering and IT, they are all merging. The most successful people are the ones here. Any question? Because I just wanted all of you to take this message, that where it is. Because when I studied, I was here 45 years ago, here, 1979. Then I was lucky that in 1985 I was able to move here, and I've been specializing here. But, but in this part of the world, what I see there is that new industries are coming. They're already coming in this and this because there's so much modernized. Because whenever you start anything new in Asia, they are all starting in this place. And when you go to the United States and others, many of the refineries and others were built 50 years ago. So in that way, I mean, people who live in this part of the world are lucky. They're young. They're able to learn these things faster. So you guys are really lucky to get into this, where your fundamentals of engineering is going to help with the knowledge of information technology. Okay. That's what I meant. So we saw about information technology. So this is one important slide I like to talk about is data. So many people keep using the word data, information, back and forth. So I just wanted to tell you that data is something that is raw, disconnected points, often chaotic and unstructured. That means, that's a point, you see a temperature, you see a pressure, you see, some picture you take somewhere, they're all data. But unless you go and organize them, hey, these are all the temperatures of this particular distillation column top. These are all temperatures of the train number 17. These are all the temperatures at the bottom of the column. And these are all the heat exchanger outlet temperature. Then what happens is you put them in the right structure. And these are temperatures in the morning, these are temperatures in the afternoon. Then you start taking this information and then trying to connect the information. Hey, this is my temperature, this is my pressure, this is my flow. Then you start connecting, hey, you know what? Distillation column flow. Yeah, this is a feed, and this is a temperature, and this is a pressure. If you start reducing the pressure of distillation column, and if I don't do enough, then I may go to flooding. So what happens is you start connecting knowledge. When information properly organized and many of the informations are connected, they lead to knowledge. Then what happens is, after this is very good. Just take the cooking analogy, right? You guys watch YouTube and then start looking, hey, I need this, I need this. Then you start organizing, these are all the ingredients for cooking. Then you go and say, hey, this is an amount, and then you start mixing, you do this, you do this, you do this. But if you go to your grandma's house and you see a tasty food, and she puts this, she put this, you sit down and say, how much you're putting? I do that in the lab. But you find that she cooks almost within half the time you take, and then it's twice as tastier. Then that is where the wisdom comes. Right? So that's what happens in this. People keep on, learning as the learning matures, knowledge and experience learn from multiple trials and error. And that is where, the wisdom is what you guys have to work on. Because many of the artificial intelligence and everything, you can use this to speed up, connect knowledge, give you, remind everything. But at the end of the day, what they call as artificial general insurance, artificial general intelligence, AGI, they talk about, that is where is the wisdom. This is where is the connection between human and the machine. They can help you. So what you can do is you can start using the same tools to go and jump, and you don't have to wait for 80-year-old grandma trying to learn how to cook. If you use the information, then you can start cooking as good as your grandma in 2 years, because you have to gain your wisdom. So that's a message. You want to say what is that? Data, what is information, knowledge, and wisdom. Any question? All good? Okay. So, first principles of science and engineering. So, this is where I wanted, this is what you guys are doing now. In science, forms the fundamental for engineering, right? It's mathematics, and mathematics is basics. And then you start learning about law of thermodynamics, governing energy transformation. and Newton's law of motion explaining the behavior of physical systems. And then basic law of chemistry, you know what's the conservation of mass, energy, balancing, and what are the compounds, bonding, and everything. Most of you guys are familiar with, right? And then you also have chemical thermodynamics. So these are all the fundamentals. And in engineering, you take the science principle and solve the practical problems because you do all in the lab. But whatever you make, they have to be commercially viable, and you don't want to have pollution. You don't want to have accidents. So it has to be, so that's how you get into engineering, and that's what's our job. Because most of the engineers are responsible for that. So in civil and mechanical engineering, we use mechanics, material science to address structural challenges. Chemical engineers, we apply a law of chemical kinetics, heat transfer, and material balance to design efficient chemical plants. And in electrical engineering, we use the Maxwell laws and others to design advanced circuits and communication systems. So science law. But many times the fundamentals are very important. You start with simple math, you start how to communicate, then add from math to science, science to engineering. But in any place, if we are not careful and don't understand the fundamentals, end of the day we talk about it, but we don't know how the fundamentals are. And that's again, I tell you, you can use these kind of AI systems like ChatGPT and others to start working on the fundamentals, so that you can always go through the fundamentals. It's not advisable to use ChatGPT and write your project and then send it as an assignment, but it's always better to use that as a tool to go and refresh your basics. Because I find, because if you want to go to your seniors and ask them, hey, what is this? Or you want to go to your teacher and ask him, you may be worried, hey, you know what? He might ask you, hey, don't you know even that? So you don't have to worry about ChatGPT and all. You can ask any questions you want, right? You don't have to, because there are many people who are afraid of asking fundamental questions. I should have learned it level. How can I ask it? But you can go and ask him. So that's why I'm using it. So, because if I go and ask you my son, he would say, oh, you didn't know that, Dad? Now at least I know I can ask all the questions. So we can always use those tools to do that. Next one is AI. How many of you are familiar with artificial intelligence? You have done some courses in LinkedIn or other media. Any of you guys? So, the artificial... That's good. Oh, which one?
Different IIC7.0.
Okay. Yeah. So what happens is, nowadays, awareness of artificial intelligence and using the tool is like my days trying to use scientific calculator. So it is not something that it's a skill where you can just live on it. It is, you have to have a basic skill that's called domain knowledge. So you have to be strong in whatever chemical engineering, whatever it is, but this is just another tool. That's all. Many people say, I want to go and do AI, I want to go in ML. But what I have done based on my experience, when I learn ML and AI, but always go back to see how I can help for heat exchangers. How can it help you to predict heat exchanger performance? So always your domain knowledge is very important. So what happens is, it speeds up learning domain knowledge, it removes some of the unnecessary work that you need to do, that saves you from. So I would encourage all of you guys to, and if you want later on, I can give you guys, maybe you can choose some leader here who can communicate with me. I can give you a step-by-step minimum things that you can learn before you graduate, so that you don't have to worry about, treat it just like a scientific calculator you will use. Okay? So everyone has to learn the tool. It's not a big thing, very easy. If I can do it, you can all do it. So next one is, so definition is AI creates systems, simulate human-like cognitive ability, and it is a very diverse field. Machine learning is algorithm learned from data to make predictions and decisions. It's all very easy. So, if you go, I talk to fishermen, and then the fishermen, they go and catch fishes, prawns, and they have a conversation. He exactly knows which day, which month he can go and fishing will be good. He knows what is the moon, and sometimes you have better waves, less waves, and things like that. So he exactly knows all those things, and that knowledge is not properly recorded and transmitted. So what is happening now in machine learning is all the features that the fisherman needs, they're all put in what are the catches he made, and you create an algorithm that already helps people. Hey, it's the right time to go and fish in this distance, and you can catch honest fish at this time of the day. So it's all simple statistics that you've studied in school, simple math. But because the computers are cheaper, all the programs are available free sometimes, most of the time. So you can always do that. Then natural language processing is understanding and generating human language, like chatbot translation. So what happens, we're all engineers. We always do science, we always do all mathematics and everything. Sometimes we are not salesmen. We do not know what we think and put them in nice words and make it presentable, right? That's for all of us, I agree. But what I found out is when you start using this tool, like natural language processing, is acting more like your English professor. Because what they do is they put all the 60,000 books that are freely available, and they put a lot of communication. Then it generates his own way of talking, how one word has to come with other words. So then you start adding your domain knowledge into it and say, hey, can you write a report like that? It's able to use all the languages it learned. So it is only helping us. It's not taking our job, it's only making our job look better. So that is one thing I'd say. Then the computer vision. Computer vision, this is one thing I wanted to tell everyone. We have only 2% of our brain weight is compared to the whole body. The weight of the brain is just 2%. And the brain needs 20% of our energy, right? And of all the 2% brain weight that we have, all the effort we have, almost 2/3 of the brain power is all we get from vision. So, we hear, we taste, we touch, but still show it. Show me how it is. So what happens is vision becomes very important. And sometimes, the vision is what, when the operator is there, they say, hey, can you go and check? Because even though temperature tells you something, pressure tells you something, we send the operators, can you check? So that is how this AI is coming. Because even if you go those days, we sit in the tolls, and then somebody will sit there, you pay the money, and they open the toll. Now you see, he has put that code, and then they just scan the code. Because it's again using these kind of vision technology. And you handwrite something, it picks up from the handwriting. So what is happening is, for us the vision is very important. Like, as a chemical engineers, initial days when I worked, there's so many pollution, so many tolling, benzene, everything will be there. Nowadays, what you can do is you can always set drones with cameras and everything. You can check those things. In the places where we were, in Canada, it's so cold, some places we used to have bears. You don't want to go and wake up a bear. So we use these vision ones to monitor that it's the right time to go there. So it'll be monitoring instead of choking out, So it does not work. So vision is something very important, and that's how Tesla and other all those things work. There's heavily automation. So that's and robotic design. So this is about using robots instead of others. And game AI, mastering games like chess, Go, you guys know. So all those things, they are all part of artificial intelligence. So, okay, I talked about data. I talked about first principles, right? I talked about what is artificial intelligence, but how they all come together is where this part is. So what is happening is, I told you about data, and the data has to become information. So this is something you have to know. the data is this time, wherever we go. Because we never do, when I was there, even these data were not there, we were used to it with pencil. But these days you have quantitative data is measurable. That is the data that you can see the sales figures, temperature reading, you do your lab and you take all the reading. It's a quantitative data. And then qualitative data doesn't have number. You can just say, hey, I keep on adding load, it gives a sum, then you say, hey, it's overloading. So sometimes it just shuts down because of overloading. Because you start tightening the belt, you check the load test, whoa, you see those are the motor stops, right? So these are all the ones that we see is quantitative data, and then binary data is yes or no, and then time series data is some data of morning temperature and evening temperature, so they vary with time. Say for example, heat exchanger, when you clean them, they do good job. But heat exchanger, when they, over a period of 1 year, 2 years, 3 years, slowly they have a falling and performance goes down. So these are all time series. The next one is text data. That is, somebody goes and says, hey, I go and check everything, and this is what is the temperature, and then operator will write something in his own handwriting. These are all text data, they are totally unstructured. Everybody will write their own, and depending upon their language skills and how they see it, and that data is very important, but we can't see it. And the other one is multimedia data. That is, you get audio images. You go and camera picks up some fire or smokes are there. These are all the data video that representing Dan's data sets. So what is happening here is the text data, manual data, and everything. Like I put it here, when ice floats on the water, only 1/7 of the ice you see at the top. Almost 6/7 is in the bottom. So many boats or ships, if they don't know, they go and hit them, they break. So just like Titanic example, right? So what happens is all the information that is buried, which can help engineers to troubleshoot, solve problems, these are all the data that is not structured. So that is what the artificial intelligence, large language models, because they've been trained on understanding languages. Because how many books you and me can read in a lifetime? No, not 30,000 books. Because we may know many words. I don't know, most of you guys who know Tamil here, right? Because we are familiar with many words in Tamil. But when we ask us to speak some words in Tamil, we use this. We can only use few words. But if somebody writes a Tamil poem or anything, we can understand. So familiarity, it's a nice song, but you won't know if you ask it to write, you can't write it. But the large language models know how to explain these things. So it will be able to go and categorize, hey, this is a word, where does this word come from? Say for example, Apple. So I'm a merchant and I'm using Apple. Is there any other thing I can buy? And I say, hey, I'm a computer scientist, I'm using Apple. That means the system, because they've been trained, it knows apple from merchant is a fruit. So it say wanted to look at oranges or grapes. Whereas, if you say you're a computer scientist, it knows computer scientist with apple means, hey, are you using Apple? Have you ever tried Linux? Have you ever tried Dell computers? So it knows the context. So that's why they are helpful to understand the context. Because whenever we speak something, we don't know the context. So this is the advantage of large language model connecting and helping engineers. Okay. So this is the part I wanted you guys to take it. And understanding unstructured data. What is unstructured data? I already told you, reports, manuals, emails, multimedia images, video, lack of predefined format. So the reason is there's no point in taking all this and trying to say, hey, this belongs to engineering, this belongs to civil engineering, this belongs to this. You just throw it because using those words, Ohm's law, this, you'll be able to table it. Then maybe that should belong to electrical, that should belong to chemical. So it doesn't work for you. So design structure. Then iceberg and all, that's why I say, these are already explained to you, that all that structure formats of Earth. So you can always see, that improves communication. And that's the advantage of using these kind of AI models for communication. So, I've been talking large language models. I'm again summarizing this. Simple AI tools, large language model is an artificial intelligence system that can read, understand, and write text like human. So we just wanted to say, hey, what are the things I should consider to operate a distillation column? Because they've thrown in a lot of distillation column stuff, and if you properly give them the right answer, you'll be able to give you this. And then you have to know a little bit about distillation column, because sometimes it may give you a wrong answer. But I find that it's not 100% perfect, so you need to have your fundamentals right. But it's going to help you on that. Then it uses brain like neural network. How many of you guys are familiar with neural networks? Yeah, that's also a very simple one, because some of you guys are familiar with identifying equations and things like that. Neural network is also like that. It's very easy to understand. So then learn from lots of data. So I told you, train on a huge collection of data, articles, web content. I don't think you and me can do it. They just do it. They just throw in a lot of computer power and spending billions of dollars to make those things. They've already done, and many of those things are available for free for you guys to learn. And it's useful for engineers because it can assist in generating reports, summarizing technical documents, and coding for simulation. Because you don't have to read all the 50 pages of document. You can take the document and put it here. It's going to give you a nice summary. So if you want to read 200 documents, you can just go and give the link. It's going to give the summary of that. So that's why I just want it helps you guys a lot. Because for me, those days we had to read a manual, I had to go to the library, somebody should have already issued it out, I had to wait and read. But these days you can just give a link and then you can understand this. So some of the large language models, there are open source models and there are large language models that are proprietary. So ChatGPT, Claude, Gemini, these are all the ones you can use. And if you pay additional, they give you additional extra privilege to do that. But if, you, as a student, you guys are running on time budget, so I would say Llama 3.2, DeepSeek, these are all the languages that you can download. There are different sizes available, you can put it on a laptop. If you guys need, and maybe you guys can arrange a meeting to go through the demo, not today. So if you guys are really want to test some of the tempting fundamentals, you can do it. Okay? Unveiling the power of unstructured data. Again, I just want to give you some examples here. When I say large language models, I told you large language models is an English browser. It just knows here and there. It's a jack of all, but you are the master. So you have to drag in how you want them to speak to you. Okay? And having a list of structured data is not enough to fully understand the complex system and the interaction. That's why I already explained to you guys this. Let's say we take a pump. Okay? You guys have already done your lab, right? You just had a pump, you had a bucket, and then you had a stopwatch, and you said how the pump is performing, and maybe that's one of your lab, right? So, if you take a pump, you have a pump draw. You have performance pump, you must have generated a performance curve. And I open the valve, see this is a flow, this is a pressure, so pump performance curve. And then you have engineering specifications. How did you buy it? How do you specify the pump drive? And then operating temperature, fluid migration. See, the one I put them in blank is a structured one. Because engineering specification, you can see digitally, it will say this flow, designed for this. Temperature, flow, you measure the structure. But operating manual, performance curves and drawings are unstructured. But you need, so you need to go and look at all those things. It's going to take hours. Sometimes we are too lazy to even bring everything and see it. But these kind of, if I just take this drawing, put them into some of these large language models, they were able to interpret and then connect all this and say, hey, what, you're not correctly running this and you are outside the design domain. You can make a question. So that's an advantage of this. And then I want to go through another example. Take a heat exchanger. Heat exchanger, every 1 or 2 years, whatever, whenever they take it on maintenance, they go and check the heat exchangers. Hey, how much is the tube plugged? Is there anything leaking? So they have a complete inspection report. What do you think? Inspection report is not structured. If somebody writes in their own handwriting and something typed, something written some statements, and then engineering specification, yes, what's heat exchanger, temperature, pressure, it has a structure. And then temperature, flow, pressure for every day, every minute, it has been recorded for 5 years. So you can say last year, you can say 2 years ago, now, and one of the things, I went through 15 years of data. So they had every minute 15 years of data of pH, flow, and this, and they have 15, 20 years of inspection data. Then you can see how we ran the heat exchanger and what was responsible for its failure or corrosion, those things, right? Then what you can do is, as a homework, you guys can think about it. So you can extend the unit operations like reactor, distillation column, compressor, dryers, crushers. You can always take all the documents of that. So then this is what is again I'm analyzing engineering controls. So what you can do is you can analyze operating trends, because of whatever, if you're in operation, you guys go to operations. You just don't have to go to the operator and say, hey, what did you do? How did you run the plant? No. You just take all this data, put it in those systems. They're going to tell you what, we had some problem like 1 o'clock to 2 o'clock. Why? Because some pump stopped. So you get all this information. Right? And same thing with the administrative control is use data to analyze procedures to clarify. So you ask people, hey, you have to go there, you have to wear a helmet or something like that. Sometimes you're not sitting here watching a helmet, but nowadays they have the camera. So if anybody is going to do the work and it is not having hat mount, it's going to stop it. You can't even cross the gate. So these are all the things that they use these systems to do. And then behavioral control. So that creates a behavior. Right? So, once they started putting a lot of cameras, in many countries, the trying to steal from people and everything has gone down. But at the same time, what happens is the behavior, even the plant, people think because going helmet is, they are achieving a great thing. No, you're putting other people in danger, you are also in danger. So these are all the things that you do administrative control. So what it does is, if you have these kind of systems that avoid accidents, so they will use, and think of information is not structured and is important to connect and contextualize. So what we do is, we are not here to punish operators, but we go and see, hey, why, there are many cases where I've used the system. It says, many times these things were just doing a lot of alarms. And I was just analyzing, and we had to have a coaching time with him. Hey, why are you doing that? Then we found out that some of his fundamentals were missing. So we brought him back to the simulator. It's like a video game, asked him to train on the simulator, and then got him back. So these are all the way you use people not to punish, but because they may not even know that they are making a mistake, right? This is how they are operating, but the way they operate when there are some situations. Then, so the conclusion is, large language models play a key role in communicating unstructured data. Advances in LLMs like reasoning models will help us learn and refresh. Most important, I want to say again, is AI is a great brush for the painter. But painter decides what to paint. So AI is not going to paint for you. So this is what I have. And you can think about it. try a few chemical engineering problems in the book using mechanical accounts with the Ranganathan model. And you can see that if some people have time, I can always go through the demo. So what I've done is, I don't know if you guys use mechanical book for unit operations. Okay, so every book at the end of the pages, you have so many examples. So what I did is, our professors, they used to take you do two, so they give to people, so the batches will do 2 of each, because it's impossible to do all of them. But what I tried is, I had my mechanical theory that I studied in 1977, that's what 4 years. So I used to take some of the problems. I'm trying to use ChatGPT and take a picture and say, hey, can you solve the problem? It did it. It's not perfect, but at least it gave a nice structure of how to do it. So that's how I find that you can even use those to solve the problem, and goes through what all the steps it took, and that's how you can learn. So I tried some of that. And so what you guys can do is you can try. That's what I count as lifelong learning and how to use them. Because what I've done is, imagine that you are studying mathematics. Mathematics builds science. Science builds fluid mechanics and basics. Then fluid mechanics and thermodynamics, you build some of the unit operations. And put all the unit operations together with chemistry, you build unit processes. All those things have so much connection. If you are not perfect in one, then you slowly start bypassing each of them. So what happens if 1 to the power of n, if n is infinity, you're 1, always. But 1 to the power, if it's less than 1.9, then 0.9 multiplied with 0.9 is 0.81. 0.81 to 0.9 is 0.72. So if you have multiple systems and you're only 90% perfect, if the systems are too complicated, it will be 0. Right? That is why you can use this strategy to do the curriculum learning. So the base, you can make the fundamentals always clear. Because many times what happens is we are afraid of going back to our school age, and we think, oh yeah, I should go and read what I studied. But you can always use these tools to go back and refresh it. And you can do it almost 1/10 of the time it takes for you to read the book. So this is what I was thinking. Now, these are all the references. I'm going to send the PowerPoint slide to HOD, so you can always take it. And that's all I have. And take some questions, and because I don't want to stop you guys from going for lunch or anything. If anybody is interested, then I can always work with you guys on some of the examples on how to use ChatGPT and things like that. So any questions so far? Go ahead.
Sometimes ChatGPT can be wrong, sir. Sometimes, for example, sir, I gave some details and I need answer for a question, sir. When I compare it with in a book and this, it changes the answer is different.
Yeah. I don't know if you tried it now or before.
Sir, 2 to 3 months before.
Okay. So what I have seen this, you are absolutely correct, and that's what I'm slowly, because in ChatGPT, and there is something that came from China called DeepSeek. So what they are doing is, earlier when ChatGPT was studying, it was just going through, because they will not be trained in your area, may not be using the words that you have used. So they were all like that, so I had a lot of funny things, just like you. So what I'm using is, there is a reasoning model is available. So reasoning model, whenever you ask a question, it is going to go through the reasons. It's going to think, I'm trying this. I'm trying this. So if you start using those reasoning model, then your chance of thinking this is better. And then the words that you are using, many of them may not be trained, because people very specific to some chemical tolerant or they may not be trained. But if you are going specific to NBS culture, net positive suction rate, or centrifugal compressor, or pump, they have more knowledge. So more specific, you go to, I want to know this particular chemical, maybe it has not gone through, so it will start. And that is why they call it as hallucination. That word is hallucination. So what happens is, in ChatGPT and other languages, the free languages, they do something called RAG. So what they do is, whatever is your domain knowledge, those information they feed to ChatGPT. Hey, you know what? You are a good document writer, but you don't know anything about engineering. So you feed more data about this operating manual or your car operating manual, specific one. Then it picks up all things related and it adds its English mastery to it engineering code. So that's RAG is called retrieval augmented generation. So you have to add in, and when you see that kind of hallucination happening, that means you have not trained on your specific one. That is why you have to, because you shouldn't be using chat. We are not doctors, right? So you shouldn't be using ChatGPT to how to treat your grandma. Definitely. It's because you don't know anything about medicine. So if you don't chemical engineering those fundamentals, that's very important. Good question. Thank you. Anything else?
Okay. Going to a lab or a quantum networking. Let's say I have a complex problem, I want to solve it. Either two of them on separately. What should be my choice of going okay? By having a quantum computing.
Actually, I don't know about quantum computing. I'm just learning. But what I do currently is mainly on AI. I think quantum computing is they are working on it. So that's going to be, so far I have not used any of them in my studies because I'm just seeing the more of the science. But right now in AI, they use a lot of GPUs. Chips, and then they want to go to the quantum computing. That means they want to do more spreading. But I have no experience on that. So my knowledge is only the application of AI. If I know, I'll get the answers.
Yeah, I heard I once tried to download an open source model. When I searched and I found that Gemini is an open source. It's an open source.
You know, all those companies, they have certain models, primitive models that they were available. Say BERT. So some of the models that they started, the basic models, you can always download them because Google's right. Google, so they all have BERT. So then, Microsoft can challenge. Right. So these are all the open models. I've just given the top two that were famous so far. But if you guys need anything, and how to even load it to the computer, I can always give you guys a link. So Pi is on the one. So you can start trying them, trying those models, and then they are good enough. If you want to try, some of them are good enough. Yes.
Yeah, Llama 3.3.
Yeah, Llama 3.3. You need a big machine. Yeah.
3D, I can run it.
Yeah. And then you should try DeepSeek. Have you tried?
Yeah, I didn't.
Try that. Because if you try DeepSeek, you will get this answer. Because DeepSeek gives you DeepSeek that gives you a reason. So it's very good in mathematics and Python coding. So I like that. And all of you guys, how many of you guys know how to code in Python? Raise your hand. You don't have to. How many of you tried Python? Right? Anybody? So I think that is something very, because this coding is not difficult, because it's not, Python coding is very simple, but what are all the libraries are available in Python to do all your, so if you know Python very well, you can do all your homework quickly. You can always confirm, and you can even ask the ChatGPT to use a Python code. It gives you, because when you do a Python code, say pump calculation, you just create a Python code and you can solve all the 10 problems related to forms of that. So I always encourage people to start learning Python, because many people think, I'm not IT, I'm not going to learn Python, because I've been coding for the last 7-8 years in Python. But it's more like a hobby. I start because I manage people. There are cases where I manage 100 people, but I still spend 4 hours a week in doing these documents because they are very important. So I would strongly encourage, trying to learn Python basics, and they are all available free. And then only thing I found out is if you guys want to learn Python language, don't do it alone. Go as a buddy. Go as a team of 4 people and learn. Because then you guys start challenging each other. Yeah. Any questions? From girls side? Any questions? Any questions? Okay. Maybe I need some help to get to my ChatGPT here. I want to give them a demo. Please. Yeah, this is something, I just finished my regular lecture, and I just tried some of those things I want to share with you guys. So this is something, let's say, this picture I took somewhere, and then I just told the ChatGPT, hey, I just want to know what are the things that it has gone by. So it is just going and explaining, hey, it goes over rectified sections, stripping section, feed, condenser, so it's able to do certain things. And the kind of setup is essential for chemical industry for purification and concentration of liquids. Maybe let's say I have ethanol and water, how to design a column to distill and purify ethanol. Then it goes through purity, recovery rate, so it goes through all the steps. And then analyze the simulation. Then I just, sometimes, I just want to tease you because I told you guys about the unstructured data, so I just design the tower. Just gave that example. Then it goes ahead and say, metal balance, ethanol, this is just, just assume some value, never right, but at least it guides you in some direction. TDP calculation, sizing, simulation. Can you use McCollum to estimate the number of trees? Then it goes through this McCollum equation and estimated cases and say, can you carry out calculations? I don't think they're perfect, but what I found out is use all those things, right? Then it gives you your data, what is your yearly data, and then use some approximate data pair of pan for the year, liquid equilibrium. And then, I wanted it to give me a Python code on plotting, so it has given a Python code on plotting, and then code examples. So, and then I also created my character. So I've created explain process. So I created my own kind of first principle man and told I'm a chemical engineer, then specialty, this is this. Then what does chemical thermodynamics apply to reactors? So you start defining your role and some specialization is going to go from being an English lecture, it starts to collect all the things around it and then starts giving you free energy and all those things. And you have to go progressively, that's all I said. You see this Lewis equation of enthalpy. So all those things you can learn them. So I've tried all those things, that's why I'm taking all my mechanical books and things like that and going through this. And sometimes, as you said, there are some hallucinations that I need to do. And one advantage of using lava 3.2 and others, what you can do is, what causes the hallucination is the parameter called temperature. So you can go and make the temperature lower, that means you will more realistic. So that's the advantage you have in ChatGPT. Also you can do it, but you need to pay a lot for ChatGPT to run the program. Because the moment you use ChatGPT as this, you only pay minimum. But if you are running a program to go back and forth, application programming for every question and answer you have to pay. But in Llama, some of the modules you don't pay, so you guys can try. Then one example I have is so this is something I said, I calculate PSH per centimeter pump, the height is 3 meters, pump and I put pipe length purposely because I wanted to understand pipe length. It's 15 meters, 4 bends, section 4 inch, it's a typical unit operation one. And we find that, though the MPSC calculation, just to 30 seconds, some came about estimation of friction losses, there was an history and what I found out in many cases, they struggle in unit operations. So you have to use your concept that doesn't understand how to do some conversions. So at least the steps seem to be okay, but the calculations for unit operation are good. So I want you guys to, but some of these Darcy situation, they are good, but some of the calculation makes the approximations we should do. And I get the complete Python code. So it assumes, you see, the gravitational ones, so that's the pressure. So I find, the variable pressures when I write, but at least the concepts are good. So I'm just sharing all those, like the one you said, it's not perfect, but at least it gave some of those. Then I tried, so I had a lot of work I've done on visualizing diagnostics. So how do you use process engineering? How do you do anomaly detection? How do you use rule-based maintenance models? And then what is process control, quality control? So I got some of these work. And I find, if you have the fundamentals, and how do you in the control system, if you're doing the set point, what are the internal absolute error, internal square error, all those things you are right. So it's able to directly, if I know the fundamentals are what are recollect, they seem to be a good tool. And some of the advanced diagnostics, it gives you how do I know and tune those controllers. So, what are the steps I should take fundamentally to the controller? So it gives you all the steps, they all seem to be okay. So sometimes I say, yes, I know the steps, but they are routine and people miss it. If I dump data, can AI analyze data for the previous one? It just tells me, hey, you give me all the process value, set point, output of the control valve, then it gives you all the steps for you to do. So this some of them I can go on and on. So I have hundreds of pages of this. In a pocket. Yeah, that's all I have. So we have. So you can play with it, but always take it with a caution, because don't try to cure somebody knowing about medicine or something. It's good. It's just a curriculum way of learning, and that's what I have. Any questions? Well, thank you very much for your time.
I'm Sriman from Chemical Engineering career. I thank sir for a very wonderful lecture. Thank you for spending your wonderful time with us. It was very informative. And, we come across AI every day. I was using AI Thank you. Thank you.